finding the limits if it exists. The first thing when we try to find the limit is just substitute in the number. So here x equal to -1, so we let x equal to -1. Substitute into the top and at the bottom. Notice that here we do not write equal sign here yet, so it's not equal yet. Right, now we just do the math here. The top we have 0, the bottom is -2, so 0 divided by -2 is 0. It is a defined number, so we'll make it equal to. Only then we can make it equal to if this is a number that is defined. Right, so that is the first one. Next, we try to find the limit on x equal to -2 of x squared plus 3x plus 2 over x squared minus 4. We'll do the same thing. We will put -2 on the top for x and -2 at the bottom for x. The top we will have 4 plus 2, 6 minus 6, so that will be 0. The bottom also 0. Now 0 over 0 is indeterminate. So if it is indeterminate, we certainly cannot write the equal sign here because it could be anything. So we have to do it differently. What we can do here is even we have 0 over 0, but that definitely helps us. What we have is a theorem. It says that for polynomial, if f of c equal to 0, then x minus c is a factor. This works for every polynomial. So go back to our problem. Because the top equal to 0 when we put x equal to -2, so it has to have x minus a -2 as a factor according to that theorem. Uh, x minus -2, I just write x plus 2. So we say x minus -2 same as x plus 2. We should have x plus 2 on the top and x plus 2 at the bottom because both the top and bottom equal to 0 when x equal to -2. And then we just have the remaining factor. To get to 2, suddenly we have to have an x here. So whatever the numbers here multiplied to 2 have to be equal to 2. So that's going to be plus 1. And similarly at the bottom, it have to have x minus 2. Because 2 times -2 is -4. Right. So that's what we have. Now both the top and bottom have x plus 2. It will cancel out. And so we'll have limit x go to -2 of x plus 1 over x minus 2. We will substitute -2 in for x again. -2 plus 1 and -2 minus 2. That equal to minus 1 over -4 1/4, which is a defined number So we make it equal to. Next, we're trying to find the limit when x go to 16 of x minus 16 over square root of x minus 4. So we do the same thing. We put in 16 and see if it is defined. So 16 for x. We have 0. The bottom 4 minus 4 also 0. Once again, this is indeterminate. So that doesn't help. Uh, we can say that the top and bottom will have the factor of x minus 16, but we're not going to factor here because we have the square root. So if we have the square root, we try to get rid of that. A way to do that is to multiply by the conjugate. So if we have a minus b times a plus b, so that could be a squared minus b squared. So do this, we can get rid of the square root. Right. So we multiply the top and the bottom by the conjugate. The conjugate is whatever with the square root, because we try to get rid of the square root of x. So we should multiply by the conjugate of the bottom. So the conjugate will be square root of x plus 4. So we do that. And we can use the formula, but I just multiplied out. I will not multiply the top. I just multiply the conjugate factors. Because go back to the theorem we have earlier, both the top and the bottom equal to 0 when x equal to 16. So the top should have the factor of x minus 16. The bottom also have the factor of x minus 16. So since the top have x minus 16 already, I don't want to multiply it out. Just multiply the conjugate. Square root of x times square root of x. I just go very slow here. Square root of x squared, and then plus 4 square root of x minus 4 square root of x minus 16. And then we simplify. Square, we cancel the square root. 4 square root of x minus 4 square root of x minus 16. To simplify everything, we should have x minus 16 on the top, square root of x plus 4, and x minus 16 at the bottom. I just want to go back to that theorem once again, because both the top and bottom equal to 0 when x equal to 16. They should have the factor of x minus 16. And as you see here, in this, they do have the factor of x minus 16 to cancel out. So we will have x equal to 16, and that's just square root of x plus 4. So this is very easy. Just put 16 in for x, and 4 plus 4 is 8. That is a defined number, so make it equal to. Now we will find the limit of a piecewise function. This is a piecewise function, and it breaks when x equal to 2. So we have to worry about when x go from the left side of 2 and where x on the right side of 2. So we find the limit x go to 2 from the left hand side. Alright, so if we go from 2 from the left side, it have to be less than 2. If it's less than 2, we're going to use this function. So f of x is equal to 2x minus 3. And then we just put 2 in for x. We have 2 times 2 minus 3, and that is equal to 1. It is the defined number, so I make it equal to. So that is the limit when x go to 2 from the left hand side. Now on the right hand side, we'll do the same thing. On the right hand side, if x approaching to 2 from the right hand side, x will be greater than 2. So we have to use this piece of the piecewise function. Now the function will be equal to x squared plus 1. And I'm going to put 2 in for x. And that is equal to 5. We will make equal to the limit. Now the left side go to 1, the right side go to 5. They are not the same. So we say the limit does not exist. The limit approaching 2 from the left is not equal to the limit x approaching 2 from the right. The limit when x go to 2 from both sides does not exist. So the first thing when we're trying to find the limit, you just put in the numbers. If it is equal to a defined number, that will be the limit. If we have 0 over 0, that is indeterminate, and we have to try something else. If we have the square root, try to use the conjugate to get rid of the square root. For piecewise function, we have to consider the one-sided limits, and that's what we have.